Qualitative Analysis. Experimental objective: to be able to perform chemical tests and be able to observe and confirm the result of these tests to identify the identity of ions and the reaction taking place in the solution. For this experiment, the first week you will begin by testing solutions for cations and anions, for which the ions in the solution are known. You will then proceed to testing an unknown solution for the various ions using the test that you used the previous week. The most important tool available to you in this experiment is the reaction schemes. These schemes are like roadmaps that show you the progression of tests for various ions in solutions. You will become familiar with these schemes by completing these tests with solutions for which the ions that are present are known. When reading a scheme, it is important to note what the different symbols indicate on the scheme. Even though there is a written instructions included in your laboratory manual that give more detail on the experiment, the scheme provides the bare bones of the information needed to test for the various ions in the solutions. First, you will work with the cation scheme. This scheme provides the path to test for assorted cations that are shown in this frame. In this video, an example for a positive test of the presence of silver cations will be shown. First, however, before you begin any of the tests, you must take the solution that you receive to test and split the quantity that you receive in half, placing each half in a test tube. You do this so that you have a backup in case you make a mistake in the procedure. However, the best way to prevent yourself from making mistakes in this lab and having to use the extra solution that you set aside is just to stay organized by labeling your test tubes meticulously and to closely follow the directions that are given to you. To start for the cation scheme, you need to begin by adding 12 drops of 3 molar ammonia to your ion solution. Depending on the solution that you have, you may or may not have any precipitate. In this example, some light blue precipitate was formed when the ammonia was added to the solution. As you can see here, this step is also shown at the top of the cation scheme. It is very useful to look at the schemes for guidance to make sure you're following the right path. As the directions state, the solution should then be centrifuged, which will help separate the precipitate from the solution. When using the centrifuge, there are several safety precautions that you must take into account. When using a centrifuge, it is always important to balance it. When a centrifuge spins, it is like a top, and if one side is more weighted down than the other, the centrifuge will not effectively spin. You can balance a centrifuge by placing another test tube that has roughly the same proportion of liquid opposite your sample test tube when you place them in the centrifuge. If you are working at a bench with other people, you may balance the centrifuge with each other's samples test tubes. After centrifuging for a sufficient period of time, you need to turn off the centrifuge. However, it is important to let the centrifuge slow down and stop on its own. Do not place your hand near the centrifuge while it is running or slowing down. It is important to avoid breaking the equipment or hurting yourself. Next, you must decant the solution, which you will save and test it for the presence of silver ions in group 12. On the scheme, the path that begins with the silver ion test shows all of the ions that would be tested for in this branch of the scheme, if you continued on. By following your scheme and the directions in your lab manual, you can see that in proceeding to group 12, the addition of 6 molar hydrochloric acid is the next step in the procedure. If there is any silver ions that are present in solution, when you add the 6 molar hydrochloric acid, it will form a precipitate of silver chloride. The precipitate of silver chloride confirms the presence of the silver ion. Even though this is clearly a positive test for silver, you still need to centrifuge the solution to separate the precipitate from the solution, as the solution needs to be saved for a later step in the procedure. Now, moving on to the anion portion of this experiment. You will only be testing for the anions that are shown here on the screen. In this video, an example for the positive test for the presence of carbonate anions will be shown. Remember to separate the solution that you were given in half so that you have a backup in case you need it. As shown on the anion scheme, you must add barium acetate to the solution before proceeding to the initial steps. Also, as stated in your lab manual, add 5 drops of the 1 molar barium acetate to the solution. Just as the directions state, if a precipitate forms, add 30 more drops of the barium acetate. Because this example has a precipitate, we need to centrifuge it to separate the precipitate from the solution. Both will be saved for future steps. As shown on the scheme, and stated in your directions, following on to group 11 where you will test for the carbonate anion. You will do this so by adding 3 molar nitric acid. When adding the nitric acid, you want to watch this reaction closely as you will be looking to observe bubbling and fizzing. This bubbling and fizzing confirms the presence of the carbonate anions in the starting solution. Because of the bubbling and fizzing, there is a gas that's being given off. The gas is carbon dioxide, which is a product of the reaction of carbonate with nitric acid. Just one more reminder, following the directions for this lab will make it much easier and much less stressful. Thank you for watching and have a safe lab.